Hi everyone, this is Madhav and I'm going to be walking through a quick introduction on how to use Python in scripts. By this I mean how to create code in Python that we can easily run from command line interfaces like this. If you don't know how Python works, not the best tutorial for you, though I will link a tutorial in the description about that. With that being said though, I'm just gonna get started trying to describe, what is this thing we're trying to do when it comes to running Python from a terminal? What are some intricacies in how we can make our code more reusable, which is always nice? And how can we make sure that we can customize the script, just like we customize functions with different arguments, so that the functions can behave differently, the scripts can behave differently, so that it fits our needs. So first off, I'm here in Replit. I'll leave a link in the description to this exact thing if you want it. However, you can see I just have two empty Python files right here, and I have this command line interface that I can do things in. For example, I can run a standard Linux command and list what is in this directory that I'm in. So if this is unfamiliar to you, not the best tutorial. Moving on, I hope this is familiar to you. One of the things that we want to do in this terminal is we want to run a Python file. To do that, we use the Python 3 command to run a Python 3 file. And if I just run this file right now, nothing's gonna happen because, well, there's nothing in the file. But let's say I print hello. Then if I run this thing again, now I should see hello in the terminal. So this is what we mean. We want to create Python code, but for scripts in particular. Scripts being files that we can run from the terminal. So, okay, we printed hello. It's not too useful yet. Why don't we make a little bit more of a complicated program? What I have here is, I have this markdown file. Markdown is just a text formatting language, meaning I can put in a link like this, or I can bold some text, using these symbols. First off, we're just gonna print this markdown to the console after we read it from the file. So this is pretty simple still, but it's just something for us to play around with for now. So we're gonna create a function, getInput. It's gonna take in a file name, and what we want to do is we want to print to the console the contents of the file. Except we don't have the contents of the file. Let's get the contents. So for now we'll make it an empty string, and we want to read the contents of the file. So we're gonna open the file in read mode, and we're just gonna read as is evident. Here we are. We don't need to print the contents here, we can just return the contents. And down here now we can actually print, let's say, get input for this file, input.markdown. Cool. So this is a little bit more of a complicated program than, print hello. We have a single function, and then we call the function to get the output we want, which is the contents of the file. If we try running the Python script, we see that, well, it's behaving the way we want. So, tutorial over? Not quite. We did the basic thing, but we have a few issues that we need to work around. The first issue with this code is that, let's say we wanted to reuse this function. Okay, we created a function, getInput. We wanted to reuse it in another file which I call other.py. So I could try importing this Python script as a module, and then I could try, new contents. I'm reading the file again. I want to use that function for some other file. So let's just say snippets.txt. You can see I have this other file right here. If I wanted to do this, one of the issues is, okay, let's say over here we're just printing something like other script as a result for now. You can see in this other script I'm importing this function so that I can reuse it. I have successfully reused it, and then I'm just printing this thing to say everything done, right? Finished. Now look what happens when I try to run other.py. So I'm gonna go over to the console, and then I just want to run other.py. Look at what gets printed to the screen. We have all of this stuff from file.py, all of this functionality occurring before our functionality in this new file is actually run. And this makes sense, right? Like when we import this file is going to get run, right? It's going to get run, so all of this code down here is going to get run as well. So that's an issue, right? Because if we just want to use the function, we don't want this script running and doing its thing. We just want to get the function so we can reuse it. So how do we get around this issue of trying to reuse code from one script in another script without having, all of the functionality of the first script being executed? Hope that issue makes sense. The way we're going to get around this is we're going to get some help from Python. Specifically, we're going to get some help in terms of a special variable that Python creates for us. We don't have to deal with it. It creates it for us. So I'm going to get rid of some print statements so I can show you this a little bit more easily. So I'm just going to print over here other.py. Over here I'm just going to print file.py so that we have less clutter on the console while I'm showing you this nice thing that Python is doing for us. So now you see we have file.py being printed over here from file.py, other.py from other.py. The special thing that I want to show you is this variable that Python creates for us, which is called __name__. This variable is special. You can see I haven't declared this up here, right? I haven't declared name equals something or the other. It's a variable that Python will automatically initialize for us. Now what is it going to initialize as? When I run this file, file.py, we're going to see this printed out, and then the special value that Python stored for us in this variable. The special value is this, _main. However, note something. So when I import the file from another module, right? Let's say I try to run other.py. Python is still going to have to run file.py, but it knows that there's something different about this. File.py isn't being executed because of a statement in the command line directly. It's being executed because it was imported as a module. And because of this, the value in this special variable is going to change. Let's see what it changes to. You can see it was changed to file. Hey, we have file.py. Okay, so it was changed to the name of the file. If I rename this file to rename.py, and let's make sure both are open. Again, I'll do the same thing, except I need to change my import to rename because I changed the file name. Now you see it's printing out rename because you know, the name of the file is rename. So I just want to summarize here to make sure that we're all following along. Here's the key concept, okay? We want to differentiate between a file being run directly from the console versus it being imported as a module when another file is being run. Python helps us in doing this by creating a variable that's special. It's called _name_. If the file is being run directly from the console, then this will have a value of main __. If it's run indirectly as a module, then this is going to have a different value. It's going to have the file name's value. So in this case, it's rename.py, it could have been file.py, whatever the file name is. So using this, we can like simply detect, okay, do we want to run some special functionality like we would if this is, you know, a script being run directly from the console? Or do we want to not do that because this is just being imported as a module? We can do that with a simple if statement. So for example, if this special variable it's equal to main, this is what happens when you have the script being run directly from the console, like with this highlighted command. Then and only then will we actually run this function. So we might say get input, you know, input.md, and print this to the console. So this is what the script does, and it's only going to do this when it's being called directly from the terminal. Let's run this now. So you can see there's no print statement here, right? So when we call other.py, we shouldn't see anything because this will not be true. This is only the case when we're directly running rename.py from the console. And that's what we got, no output as expected. However, when we run rename.py directly from the console, now this should be true and we should see a printout that is showing the output of input.md. And that's what we get to. Cool, that's one problem solved. We now know how to customize or how to reuse the code a little bit, which is because we can differentiate between when we just want to use the function in another file, we're just using it as a module, or when we're running it directly from the console. Now let's move on to another problem, which is a little bit of a bigger problem in my opinion, which is that we don't have much customizability in this code. By that, I mean to say, right now here I've hard-coded this value. Okay, we have to read from the input.md. What if someone wanted to read from another file? Like let's say markdown.md. They wouldn't be able to do that with this Python script without changing this Python script. So they'd need to open the file up, edit it, and then they could maybe get the functionality they want. This is kind of inconvenient. What would be more convenient would be if we could have something like, okay, we're running this script, rename.py. What if we could just specify an option like we do with other bash commands, right? Output, make the output inputs, make the inputs markdown.md. How can we get some functionality like this from our script? Again, we're lucky. Python has helped us a little bit. They've thought of this for us. What we can do is, in order to get this kind of functionality, we can use a module that Python just has built in, which is called the Argparse module. And the key idea here is, just like we pass arguments to functions, we're going to send arguments to our entire script. So, it's not too strange of a concept. In order to use this though, we have to do a little bit of setup. So this is going to take, a little bit of time. First, let's just get rid of this for now and walk through the setup, and then we'll get the program working the way we want again. So right now, the first thing we need to do is we need to create a parser object. This is just a tool that's going to help us actually get the inputs from the console into the script. The way we create that is we just use the argument parser function. Let me just check that I got the syntax right. There we are. Cool. So this has created a new parser. This is a tool, right? This is our hammer or wrench or whatever that's going to help us get the stuff from the console to our script. The only thing is, we need to tell the parser, what do we want? What do we want you to get? What do we want to get delivered to us? Which kind of arguments do we want? So in our case right now, we might just want an input. That's the name of the argument. It's going to be of type string. We can set like a default value for it. So the default value could be input.md, because that's what we were using before. We could set some other options, but we're going to save that for the last step. So here we've just set up the parser. This is the object that we wanted to, adjust the settings of so that it could do for us what we wanted. Now we're going to read the arguments. So we told Argparse, hey, you're going to be our delivery, logistics officer. You're going to get the input from the console, you're going to deliver it to us, and now we're going to unpack the boxes that we just got delivered, the arguments that we just got delivered. So we're going to have args as parser. Oh, I see. That's why we had an issue. Okay, whoops, syntax error. Okay, so we're going to have parser dots. You can see now all the function help commands are popping up. I just misspelled the module name. Anyways, to unpack the boxes, we're going to have parser dot parse args. Seems simple enough. And I'm just going to print to you the arguments that we're getting so that you can see, what's going on here. So I'm going to run this now. And I'm gonna specify an actual argument at the end. The way that I've configured these settings, I don't really need to put like a flag as you usually do with commands, so I'll show you how you can do that later. In this case, I can just put in the input I want. So let's say my custom .txt .script, whatever. So here you can see this line is printing now. What is it printing? It's showing us this weird thing called a namespace object. Don't worry, it's not too difficult. It's just like, for our basic purposes, we can just treat it like a Python dictionary for the most part, not entirely. We can treat it as a Python dictionary in the way that you can see here, the input arguments that we declared here, its key is input because, you know, that's the name that we specified. Its value is the value we sent in, my custom.script. And just like a dictionary, we can just use like the key value syntax we're used to. One of them, not both of the key value syntaxes we're used to, but we can use the input is equal to args.input. So that's not too weird, this namespace object. You can see here, name was input, so it created a key named input. From the key named input, we could access the argument that we specified in the command. So now let's use these arguments. We just had, you know, the big unboxing. We got the goods we needed. Now let's use them for our scripts. So we're gonna print to the console get input from the input arguments, not like a hard-coded value. Hope you're following along so far. So now let's show this functionality. If we put in input.md as our value, we're going to get, you know, what we expect as usual. It read this file. If we pass in a file that doesn't exist, we're going to get an error. So my custom.script, that doesn't exist. We got an error. If we pass in some other file we wanted to read, like snippets.txt, you can see it does exist here. You see we got some output. We can also not pass in an argument. So if we just don't pass anything in and try to run rename.py, then it's just going to use the default value that we specified. Oh, it's not. Okay, this is not, because this is a required argument. So it implicitly has required equals true. You don't need to put this here, because like it's not going to do anything, it's already required. The reason it's required is this syntax is for declaring what is called a positional argument. So an argument is needed in the first position. Right after rename.py, we need to specify some input file. So because this is kind of needed, I'm just even gonna get rid of input.md. We don't I'm gonna get rid of the default option because this is a required argument, so the person has to put it in, or else they're gonna get an error, which Argparse created for us, by the way. So it's helping us out. And it's also showing us this usage thing. It's saying like, hey, make sure you have this input argument here. It's not in brackets, it's required, okay? Make sure you have it. We could also, however, create some optional arguments. So to do that, I'm going to extend the functionality of our program a little bit. Let's create a program that can not only read some input markdown text, it can convert the markdown into HTML, just another different formatting language. To do this, we're going to need the markdown package, which I already have installed here, but you would need to install it. We're going to convert the contents that we receive, so let's call it markdown contents. And we'll return markdown. This is the package we're using, .markdown, which is like, I think, a stupidly named method, because what the markdown method does is it returns HTML, which is kind of weird, but whatever. So we send in markdown content to the markdown function. It returns HTML, because like, yeah, that seems like a fairly obvious name, isn't that right? Anyways, we're going to convert it, and then we're going to write this converted output to a new file. So we have like a markdown to HTML converter basically. So we're going to take in the HTML contents and we're going to write it to some output file name. To do that, we're just going to open the file with open file name, file name in write mode this time. We're going to simply write the contents to the file. So file.write HTML contents. By the way, you don't have to worry about closing the file, because the with open block automatically does it for us. Instead of putting all of our functionality over here, because that's kind of messy, I'm going to create a new function called the main function. Why am I calling it the main function? Because it only runs when the name variable, the special variable, is main. So def main, what we're going to do is we're going to get the markdown contents. It's going to be equal to get inputs from a file name. We'll need to specify a file name. We have also, I'm going to call this input file name and output file name. So we're going to get input from the input file name. We're going to turn that into HTML. And finally, we're going to write the HTML. Not too difficult as a program, not too complicated, right? Let's see if this works now. Well, it's not, because we need to put in the input. We also, as you can see here, we also need to put in an output. So this is the reason I created this more complicated program. First of all, let's just hard code the output to be output.html, and then we're going to create an optional argument that we can use to show how those optional arguments work. So let's rerun this command. The input is going to be input.txt, input.md, and you can see our program is running. It converted the markdown to HTML. Cool. The way it did that was, first it got the Argparse set up, then it got the input argument from my command here. It sent the input and a hard-coded output file name for now into the main function. The main function read the markdown input using this function. It then it then converted the markdown into HTML using this markdown library. And finally, it wrote the converted HTML content to the output file, output.html. Hopefully you're following along there. To make the code a little bit more customizable, let's say we don't want the output.html to just be like, this is the one particular file name that this script will always use, which is kind of bad, because it could keep on overwriting old outputs, right? Okay, every new time an output is created, this file has its contents overwritten. That could be dangerous. So what we could do is we could add two arguments here, both of which are going to be optional. Because they're optional, what we'll have is we're going to have an optional kind of flag. We put a dash in front of the argument name. You see, we didn't do that here, but we're going to do that here. The reason being that we want to tell Argparse this is an optional argument. So we put the flags like so. So this is going to be like a short name for output. This is going to be a longer full name for output. Both of these are going to be used to specify the same arguments. It's gonna be of type string. This one is gonna have a default value because it's not required. The default value is gonna be output.html, and then we're just gonna set required equals false just to be very explicit, so that people know, hey, this is false, like it's not required. So now what I'm going to show you is the usage that it's going to tell us, like how do we use this command. It's going to change because we configured this new argument. Let me just make that happen. So you can see here it's telling us we have this -o flag that we can use optionally to set up an output. Okay, so let's try doing that. We have input.md as the input, the output, which is optional. We're going to say custom.html. And before I run that again, I'm going to print the args we're getting back to see what's changed. And I'm going to disable this function for a sec. So I'm going to print out the args we're getting back to show you that now Argparse is using another key value pair for an argument. Run this. You see this namespace object, which is a little bit like a dictionary, it now has 2 keys and 2 values, which is very useful, right? So with 2 keys and 2 values, now we can have this input.md argument, which is required, and this custom argument, which is not required. You can see the key name in this case, it was output. So it wasn't like -- output, it wasn't -o. This is something you're going to need to note so that you're able to access the arguments. I've had lots of bugs with this, so what I always like to do is just print out the arguments object so that I can see like what is the key name I'm trying to access. So we have here the output is going to be args.output, because this is the key right here. We're trying to get this value. Now we can use the arguments by specifying this output, and when we run the script here, let's just see, and we fix this error here. Now you see we're getting a new output. So this is how we configure both optional and positional arguments, and both of these are useful because like they let us add customizability to our program. So now the last thing we're going to talk about with Argparse that's useful, well, the second last thing, is sometimes we don't really need like a entire value in these optional arguments. We just really need to turn like some options on or off, just like an on or off switch. So it's more like a Boolean value, right? Like either it's true or false. I'll give an example. So the reason the motivation I gave for creating this custom, output file name is so that we don't overwrite files. So another thing that we could do for that purpose is we could create an argument that just adds a timestamp at the end of the file name. So we could have -t, or the long version, timestamp. It's going to be of type bool, or I suppose in Python, yeah, it is bool. There we go. So it's going to be of type bool, and in this case what we need to do is we need to just specify a action that we want to take. The action we want to take is just, hey, store a true or a false value, because like we don't need anything more complicated. We don't need the user to be like, -t true, like we know what they mean. If they're putting in -t, it means turn this option on. So we're gonna have the action as store true, which, as it sounds like, it will store true. I'm gonna, as usual, print out the arguments that we're getting in so that I can make sure that this is working as expected. And I'm gonna turn off the output for a second. So we're gonna run the above. We don't need the -o option right now. I just wanna do this. Okay, got an unexpected keyword argument t. Okay, let's see where the error is. Let me just quickly go search up the docs. By the way, if you ever need to know which exact options are available for this add argument function, then you can go look up the docs. They have like a giant table full of things that you can put in. So type int float ... which types are available. Okay, the bool function is not recommended. I'm just going to take out this bool thing because it should be obvious enough. Anyways, let's see. There might be an issue there. Let's see if this runs now. There we are. Okay, there we go. So we have timestamp. You can see its value is true because we specified it. When we don't specify it, you can see its value is false. So it's pretty simple. It's like an on-off switch. If we specify it, value true, otherwise value false. As usual, I printed the args to make sure I knew what the variable key is. We can get the timestamp as args.timestamp. Let's send it in here to the main function. Over here we have timestamp. We're going to pass it on to the WriteOutput function. And in the WriteOutput function, I just want to append the timestamp to the name. So let's just create a separate section for this versus for writing the file, so that the code is a little bit more readable, which is the last issue we're going to get to, which is this code is just monstrously messy right now. Anyways, write file. Here we are. To generate the timestamp, what we're going to do is first we need to get the timestamp as a parameter. When we have gotten it, what we want to do is take the file name and we're going to split it into the name part and the extension part. And it's going to split, into output and then HTML instead of output.html. We're going to say the file name is equal to, let's have the name first, and then we're going to append the timestamp. Oh, we haven't created the timestamp. Whoops. If timestamp, let's create the timestamp. So we're going to put the timestamp here. To create a timestamp, we need the time library. I think the function we need is strftime. Cool. And this function, we basically just need to tell it like how do we want the timestamp to be formatted. So the way that I'm going to format it is have the year name, as a string, year name, and then underscore, month name, underscore, day name, underscore, hour name, minute name, second name. I think this is the right format. Let me just check. Didn't save it. That's alright. Let's run it and see what happens. So we have the name. After an underscore, we're gonna append this time string. And then finally we have a dot and then the extension. So now when we open this, we should have like a timestamp if we specify that option. So let's try running this code, and we don't specify a timestamp. You see we just get output.html. We do specify a timestamp. Looks about right, whatever. So we get the timestamp appended onto the end. All the underscores are a little bit of a mess, so we're just gonna put in like how about that? Is that a more concise format? Run again. Yeah, there you go. There's a file name that's not going to be overwritten. You see, if I keep running this, the files are not being overwritten because like the timestamps generated, they end up being different. So now I'm gonna delete all of these one by one. Yay. Anyways, this is how we customize our code. So now you've seen that we fixed two problems. We made the code easy to use in terms of like reusability. We made it so that we could very easily import the functions in this file into some other file. We also just fixed this problem of, is the code flexible? Can we easily change which arguments we're using from the console? And now we can. The last thing we want to do is, this is an absolute mess. Okay, you cannot have, in general, you don't want like poorly documented code, but especially for scripts, this is important because you are more likely to not open this up after a year, because like, you know, hopefully you configured it so that you don't need to make that happen. You're more likely to share this online. So for example, especially if you are, you know, in communities, if you're in roles like cybersecurity, right? If you go look up online like different tools that you can use, you'll find a lot that are just like Python scripts that you can download. So this is like a great tool for creating quick code that's, you know, easy to use, and you have like lots of libraries available. The issue is you're also gonna be likely to like share the code a lot, and you don't want, you see? So here's like a Python script that's very commonly used in cybersecurity, and they configured a lot of options here. So you don't want the code to be poorly documented, because then no one's going to use your script. So let's create some documentation. The first thing is, we can just do the basics, you know, the everyday stuff that we use in general for any Python code, let alone scripts. So we can add type hints. This is going to take in a string argument. It's going to return a string argument. We can add some documentation. So add a docstring. The docstring should have a quick summary line. Reads input from specified file. It should say what the parameters are. So we have a parameter file name of type string. This is the file, technically the file path, but our code's gonna break if we have the file path, so file name to read from in current directory. We could have the return types. There we are. By the way, if you were creating classes instead of functions, then you would have different documentation. I'll leave a link in the description to this great article on documentation. This one, I really like this article. it's going to show you all of the things we're talking about in terms of documentation and for classes as well, if you're using classes. Anyways, for now we're just going to have a return type of string, and the return is going to be the file's entire contents. Let's increase our white space a little bit, copy over this doc string here, and repeat for the next function. So this is going to take in string contents, type int again, return a string. There we are. Converts markdown string to HTML. String with markdown formatting. You can see I'm doing the same thing again and again. Parameters, returns, whatever. You should not be doing this at the end, because like even for us this is easier to read and debug as a function compared to what we had before. So this is why we don't want to leave this until the last minute. The string is going to be string with HTML formatting. Here's one last function. Type int as usual. This time we're going to return none. Also, this is getting a little bit long, so I'm going to split it up into 2 lines. There we are. It's going to return a string. The only issue with, yeah, that happens on Replit. I don't know why it does that. Why are you like this, Replit? Just trying to... Ugh. Okay. Yeah, we're just going to do this one last time. So write specified output to specified file. The parameters it takes in this time, we have more than one parameter, so let's copy this over. Whoops. There we are. We have HTML contents, file name, and timestamp, which is a bool. If we had default values in any of these, we would also declare like default values. In this case we didn't bother specifying them, but if we had something like, oh, this is a bool, if we had this is default false, then we would write in default false. In this case we didn't bother because like we already have default values over here and over here. So let's just finish this up here. The HTML contents are string with HTML formatting, file name, again we could use a path, but I didn't check my code to see if it would work with path, so that might break things, so that's why I'm saying name. Timestamp, whether to append timestamp to the file name. Returns none. There we are. Okay, so already this is better. Okay, this is progress. This is the basics of any documentation with Python code. My comments are kind of bad right now because they explain what we do instead of why we do. We want to explain why we do. So here's an example of a better comment to prevent file overwriting. This doesn't just say like we're adding a timestamp, it explains why are we adding a timestamp. So this is a more useful comment. Over here this is like pretty simple, so I'm not going to bother to write it. I don't think we need documentation for the main function because it's kind of like just doing the thing, but whatever. We can put it in if you want. One last time. Convert markdown from one file into HTML in output file. There we are. We have the inputs file name to read from in current directory. Type hints as usual. This is why you don't do things at the end, because you might forget what you're doing after you've done like 10 of these and you're like, I think this is the right thing, but not sure anymore. I'm not paying too much attention. For example, this write output, it should have returned none. So this is why don't do this at the end. Go do it as you go. Alright, this is fine. Finally, here are some more script-specific pieces of documentation. The first thing you can do is add help text to each of these arguments. I'll show you at the end why we're doing this. You'll get a nice surprise. So the help text here is file to read markdown from. Over here, optional file name to write HTML to. Finally, whether to add timestamp to output file. Okay, we've done that. Another thing we should do is, because this is a script, we want to add some documentation right at the top. We want to add some documentation about script-specific things. What does the script do in particular? So we'll give the script a name. Markdown to HTML. We will give like a quick summary as usual of what the script does. Converts a markdown input file to an output HTML file. We also want to add this intro text, which should explain what does the thing do and what is needed for it to work. So we also add like requirements, dependencies. So to the Argparse time and markdown modules should be installed. It must be installed to run the script. Also, as part of explaining like what does the script do, the script can also be imported as a module with the following functions. We have get input, reads input from specified file. We have converts markdown string to HTML string. We have write output specified output. Cool. There we are. That's our documentation done. The last thing is, well, I'll just show you. So remember when we didn't use the file, the script correctly we didn't bother specifying an input, and it was like, hey, use it like this. Well, the reason that it does that is it automatically creates some help text, which is specified by this help flag right here. So if I put in --help or just -h, it will tell us what is the usage like, okay? To use this script, put in these arguments, this one's required, these are optional. It tells us descriptions, it's getting that from the help text, and it's telling us what are the different options that we can specify with some descriptions for what each of these things does, which is why we specify these help options, these help arguments in the add arguments method. What we also want to do is this docstring that we created at the top of the file, Python automatically stores that in a variable called _doc. So if we say when we're creating the argument parser, if we specify that in the description, what you'll now see if I run help again is it takes the description from the top of the file over here, and then it shows that to people. So now this is a much better looking script, you know, it's much better in terms of giving people information about how to use it without needing to like go in, muck about with the code. People can specify different options to change how the script behaves. It's much easier to send to someone else, and even if it does have bugs, well, it has documentation that makes it easy for other developers to fix this. So these are the important parts of creating Python scripts, and these scripts they're really powerful. As you can see, like when I showed you on GitHub, you can create a script for pretty much any purpose and share it with others so that they can easily use your code for whatever application you want to enable. So the key ingredients, to summarize, were we wanted to make sure the script had reusability, reusable code for both modules and scripting. We wanted to make it documented so that it was easy to debug, easy to figure out how to use it, and we wanted to add customizability, which is why we talked about the Argparse module. Hopefully you can take these 3 ingredients with you and start using, you know, the power of Python scripts for your own uses.